Chapter 12, where we're looking at limits and an introduction to calculus. In this section, we're going to understand the limit concept, use a definition of a limit to estimate limits, and then determine whether limits of functions exist. So the limit concept. The notion of a limit is a fundamental concept of calculus. In this chapter, you will learn how to evaluate limits and how to use them in the two basic problems of calculus, the tangent line problem and the area problem. Example 1, we're going to find a rectangle of maximum area. Find the dimensions of a rectangle with perimeter 24 inches that yield the maximum area. So first we know that perimeter of a rectangle equals 2 times the width plus 2 times the length, right? Because you add all the sides of the rectangle, you have 2 widths and 2 lengths. Then we know the area of a rectangle is just length times width. So we know those things. So given the perimeter is 24 inches, let's fill that in. 24 equals 2 times the width times 2 times the length. Now we have two variables here. So let's solve for one of them. So I'm going to solve for L. So to do that, first I'm going to divide both sides by 2. So now we're left with 12 equals W plus L. Then let's subtract W from both sides. So now we get that the length equals 12 minus W. So because that equals 12 minus W, we're going to substitute it into our area here. So now we have area equals 12 minus W times W. And then let's go ahead and multiply that through. So this is 12W minus W squared. So we know, first of all, that this is a parabola, so you can kind of guess what the number will be. So remembering the shape of a parabola, this is going to be a parabola open up downwards. You can figure out what the intercepts are. And so that kind of will help you out a little bit in choosing an answer for this here. Now what we're going to do is we are looking at the limit concept. And so let's just pick a number. So let's pick 5. And then I'm going to pick 5.5. Then 5.9, 6.0, then I want to go to the right of that, 6.1, 6.5, and 7.0. So that is going to be our W, and that what area are we going to get? Again, we're trying to find the maximum area. So we're going to plug in this W here into this equation to find the area. So we're going to try 5. So therefore, this is going to be 12 times 5 minus 5 squared. So this is going to be 60 minus 25, which is 35. And then you're just going to plug in the next number, so it is handy to have a calculator with you. So you plug in 5.5 into this same exact formula, and when you do that, you're going to get 35.75. Then you plug in 5.9. You're going to get 35.99. And then you plug in 6. So we can actually do that without a calculator. So 12 times 6 minus 6 squared, that is 72 minus 36, or that's just going to be 36. Now let's go to the right of 6. If we plug in 6.1, again, if you plug it in the calculator, you would get 35.99. And I hope you see that because this is a parabola, you know it's going to go down, and so the numbers are going to be reflected on the other side. So 5.5 is 35.75, so therefore 6.5 will also be 35.75. And then at 7.0, that'll be 35. So we find that 6.0 is the maximum area. And so we could write that in limit notation. So the limit of the area as the width approaches 6, and we could plug in that formula, limit as W approaches 6, the width approaches 6 of 12W minus W squared is going to be 36. And so really what we're trying to find is just the dimensions that yield a maximum area, and that is going to be 6 by 6 inches. So try this next example. Find the dimensions of a rectangle with perimeter 52 inches that yield the maximum area. Now try to see if you can figure out what is that number, that maximum number that it's going to be by thinking about a parabola, the intercepts, and things like that to kind of help you out. And then I do want you to use a table. The numbers will be very similar to that, right? We know that 6 is the vertex here. And then so just picking numbers to the left and to the right of that and just getting practice and plugging it in your calculator and filling out the table. So trying this out, you should have gotten the length was 26 minus W. Therefore, the area equals 26W minus W squared. Now again, thinking about this is a parabola. We know the intercepts are going to be at 26 and 0. So we know that the vertex is going to be halfway between that, which is 13, right? The x value is 13. And so we know that that is the width that we're going to plug into this center here. So you just plug in numbers to the left of that and to the right of that. So you pick one number less, start with 12, then 12.5, then a little bit closer to the 13, 12.9, and then go the other direction. You would find that the answer is a 13 by 13 inch rectangle. Let's try the next example. Definition of a limit. If f of x becomes arbitrarily close to a unique number L as x approaches c from either side, then the limit of f of x as x approaches c is L. And it's written in this way. So the limit of f of x as x approaches c equals L. So we're going to estimate a limit numerically. We're going to use a table to estimate the limit numerically. Now I know that we can just plug it in and figure it out. But again, we're getting some practice with this, and we're finding that we will get real numbers here. But later on, we'll find that when we try to plug it in, it doesn't work. So let's try this one. 3x minus 2 as x approaches 2. So it's giving you the number that we're trying to evaluate. So 2, I'm going to put that right in the center here. What happens when I plug in 2.0? And then we want to go to the left and to the right of that. So I find that sometimes doing these problems that picking the numbers can be a little hard. So we want to go to the left of 2.0. And so what we're going to do, something that's really close to 2.0 is 1.999. Then a little bit smaller than that is 1.99 and then 1.9. So that's from the left. Now, if we go to the right of 2.0, we're going to choose 2.001. And a little bit further is 2.01. Then further than that is 2.1. So now this is just practice and plugging it into your calculator. And so you're just going to plug it in each time. So 3 times 1.9 minus 2, and then find what the answer is, and you should find that that is 3.7. Then you plug in 1.99 instead into here, and that is 3.97. Then you plug in 1.999, another 9 in there, and you're going to get 3.997. Then when you plug in 2, you can do that without a calculator, you would find that that is 6 minus 2, which is 4. Then if you go to the right of that again, so we're going to plug in 2.001 for the x value, 3 times 2.001 minus 2, you will find that that is 4.003. Then at 2.1, that's 4.03, and at 2.1, that is 4.3. So therefore, our answer is 4. It is going to ask in the homework to use a table, and so that's why we are doing that now. So try this example. We are trying to estimate the limit as x approaches 3 of 3 minus 2x. And so 3 is the number that's going to go in the center. So that's what tells you what is it approaching. And then so pick some numbers to the left and to the right, kind of using the top example here as just to kind of help you out what numbers you can choose. So pause the video and try it out. So hopefully you chose these numbers. So directly to the left of 3.0, you can plug in 2.999, then 2.99 and 2.9. Then to the right, you would plug in 3.001, 3.01, and 3.1. And then here are the values you should get. And the answer will be -3 here.